it's a quite defensible claim anyway.
Yes.
All right, and I'm Charles Twardy, for those of you.
You didn't get a chance to sign in. Sign out. I need to have a record of who's attending. Okay, back to you, Charles.
Thank you, Deb.
And also Deb. Deb takes care of us all.
She's right. All right, so Charles Twardy. I was at the C4I Center for about 5 years, quite a while back, running a project with Drs. Laskey and Hansen, and we'll hear a little bit about that in passing, but otherwise you'll have to go back to the talk from 6 months ago for the real tie-in. We're just going to go forward with what we've done with it from there. My background was very transdisciplinary. Spent a while in history and philosophy of science and computer science. And as I was telling Kathy, a lot of people have now moved into the field that's called itself meta-science, which is the science of science, or how do you make science more reliable? And so I'll talk about a little background on the replication crisis, which is a lot of people in the field coming to realize what statisticians have been warning us about for 50 years, which is that a lot of the inference techniques that are being used in run-of-the-mill papers are not very strong. And so you shouldn't be trusting the results of any one paper nearly as much as journalists would lead you to believe. And so what do you do about that? Thanks, disclaimer and copyright. These are my own words, my own slides. We are funded with many thanks by the Defense Advanced Research Projects Agency, DARPA, because they have a social scientist now. A Rhodes Scholar and anthropologist who decided that if he was going to command the resources of DARPA, darn it, he wanted to make social science more reliable. Not that I can speak for him, but that is the vibe you get when he talks. If you get to hear him talk, by the way, he's really quite entertaining.
Tell us his name.
Oh, Adam Russell. Yes.
Yes.
Okay.
If you get the chance to hear Adam Russell, it is definitely worth it.
All righty. So, one of the ways I got into this particular topic was a beautifully titled paper, The Perils of Policy by P-Value, Predicting Civil Conflicts, where they went through a whole bunch of social science literature on people looking at various societies around the world that went into civil conflict or did not, and tried to look at GDP and age distribution and race distribution and various other things to say, how can you predict when one of these societies is likely to have civil war? Except they thought that prediction seemed a bit too edgy, so they didn't talk about it that way, but policymakers all used it as if it were predictive. And this paper shows that the models they were using were actually very poor for that, because typically they'd run a regression or a bunch of regressions and then say, well, whichever had the best p-value, the result of a statistical significance test, that's the most reliable variable. And the next best p-value is the second, and they'd cut it off at like the top 3 or 5. If you actually do model selection tests, those of you in computer science and machine learning realize, you set aside a holdout set, you learn your model on your training set, and then you actually test how well does it predict. This will not give you the same set of variables as you would get by picking just by p-value. There's a correlation, but it's not the best way to go. And what they found is all of these models gave you statistically significant, but little accurate guidance. It was really no better than chance. In social science and behavioral science, generally, we're seeing this sort of pattern pop up over and over for a number of reasons. You can go on Wikipedia and see actually a fairly good exhaustive list of contributing factors. One of the most pernicious of which is publication selection bias. If you run a study and you get no significant result, it's really hard to get that published. In fact, most people know that and don't even try. So it's called the various things, including the file drawer bias. It's like, oh, we must have just messed up. Let's put that in the file drawer, start again. Well, if you have 20 labs each doing that, and 19 of them get no result and say, oh, well, we messed up, move on, and one of them gets a positive result, guess which one gets published? Your literature is now a very biased sample, and you'd expect the actual reliability rate or replication rate to be down about 50-50. Happily, for those of us in industry and looking for R&D funding, DARPA decided this was a problem that affected them, and they wanted to throw some resources to solve it. The number of studies done on the smaller scale, and Adam Russell started the SCORE program to say, we want to scale this up to thousands of claims. We want to rate thousands of claims and be able to give some sort of reliability meter. Wired called it a BS detector, possibly because in the interview, Adam may have said, please just don't call it a BS detector. They were a little kinder in their second article on it, but yeah, there's one of the Wired articles without BS in the title. And ultimately, the SCORE program aims to develop a machine learning model. Yeah. So the vision would be you take your PDF file, you drop it into your black box, and it says 80% reliable. You know, you might want to consider building policy on that, or this is really preliminary. Better run another study. There's a number of teams performing different tasks in SCORE. We're just one of them. Our task is to forecast many upcoming replications. A separate team, for those of you who know the Center for Open Science in Charlottesville, will be running the replications. So how does this work? We're in phase 1 now, which ends mid-2020. In phase 1, we have to forecast 3,000 claims selected by the Center for Open Science from social and behavioral science literature. So journals like Cognition, or Management or Marketing or Econometrics, broadly sampled across the social and behavioral sciences. We forecast all 3,000. We're doing 300 a month, and that's work. Then they are randomly selecting 5 to 8% to actually test. And they're farming out the tests. We're blind to what the selection is, and we're blind to the results until all the forecasts are in. And then we find out how we did. My collaborators have done this before at the smaller scale, and they get about 70 to 75% accuracy. So the hope is we repeat that performance or improve it on the 300 claims that are tested, and therefore, since we didn't know which those were, we infer that we're at least that accurate on the other claims. And that gives us the beginnings of that reliability meter and training data for the other teams who are concentrating on machine learning. I think those have all been selected now. I don't know if they've been announced, but it's become public that the Penn State team is one of the awardees, and they're collaborating with David Pennock at Microsoft Research, one of Robin's colleagues.
Question. If this machine learning algorithm works, but then people get access to it, can they play the same selection game of running 20 things through the machine learning algorithm until they find the one the algorithm wants?
Yes. One of the things we're going to argue is that's great. That'll help you in the short term until people adapt, and then you're still going to need some sort of more intelligent system, probably using humans to kind of calibrate and go on. In fact, there have already been 2 or 3 published papers on machine learning methods that get 65% accuracy. But one of them used simple word-to-vec models. You know, for those of you who know it, you'll get that it's natural language processing. It's kind of cool. It's the one that lets you do the parlor trick where you say king minus man plus woman, and it says you must mean queen. So, you know, that's pretty cool. We couldn't do that 15, 20 years ago. It's run-of-the-mill now, and it's still a bag of words approach. It doesn't take account of the structure of your sentence. And so for that to be getting 65% accuracy, it's picking up on some pretty low-level signals that are easy to fake. So once somebody knew what the machine learner was, they can just pepper their abstract with the right terms, remove the wrong terms, and appear to score well. Humans are a little more sophisticated than that and take a little more effort to fool. Okay, how are we going to do this? Every month for 10 months, we put up about 300 claims, and we recruit a crowd of forecasters. Please sign up. We're interested in always recruiting forecasters. So Kathy, for those few who still remember Indiana Jones, right? Crowds, why did it have to be crowds? I love crowds. It's fantastic what you can do with them, but you know, we're all busy. We have our other stuff to do, and so we all put in a little bit of work on the forecast, and you've got a kind of care and feeding of the crowds to remind people, hey, come back, there's all these other questions, and we'd love your input. So always on edge, are we gonna have enough forecasts? So far, they've pulled through for us. Love some help. First week of every month is surveys. We ask you to look at least 10 articles, as many as you want, but at least 10 in a batch. And without communicating with anyone else, because you're all doing your own surveys, what do you think? How reliable is this? If we ran a high quality replication, would we get the same result? After a week, those all close. We run an algorithm that Harvard has been testing to estimate how well people will do once we know the ground truth. And then we put it up on the market where it's a market. Everyone gets to see the current estimate and say, hey, I think that should be higher or lower. 60%? No, I don't think the statistics were that sound in this. Or the title is just too appealing. It's, you know, way too surprising. I think it should be a little lower. Well, we let that go for 2 weeks, then freeze the market. By mid-2020, we'll know the results and actually pay out on the market. DARPA let us put a total of $150,000 up for prizes. We distributed them 1/3 for the surveys, which we can pay out monthly, but we don't know that that's really ground truth. 2/3 for the market, which won't pay until we really know ground truth. So we mix the bigger payoff, but farther away and less certain, for the smaller payoff, but happening every month. Okay, I mentioned I'm part of a team. I get to talk to you, but this works because I have a fantastic team who's not only familiar with prediction markets, but has worked in replication before. So the experiment design team is at Stockholm University and Massey University in New Zealand. They've been collaborating for a while with the incentives and scoring team over at Harvard University. So, you know, lead professors Anna Draber, Thomas Pfeiffer, Yiling Chen. At Jacobs, formerly KeyW, we do the lead in the integration to put their work together with what we developed in the bottom slide here with Kathy and Robin, combinatorial markets, still yet to be enabled in the online forecasting system, but that's the platform we're using. Like many of these research projects, a lot of the day-to-day work is done by the postdocs and graduate students. Domenico Viganola was here for a little bit. He got a fantastic offer for the World Bank, but he is still helping us out in his spare time. Felix Holzmeister at Innsbruck, Michael Gordon at Massey, and Juntao Wang at Harvard University. And on the right, the participant engagement crowd, care and feeding of the crowd. So very important when you're running surveys, markets, any sort of crowdsourcing effort. All right, the research team has published a number of smaller studies looking at, can we predict which papers will replicate? And the basic answer is, yeah, we can. So that's the project. Here is a couple of papers that have come out in Proceedings of the National Academy, Royal Society, Economics, Science, and there's a couple of popular articles that have been written in response to these. A lot of this comes from Robin's 1995 paper, Could Gambling Save Science? The idea is, okay, we're not letting you gamble with your own money because that's illegal in the US, but we are running a sort of a half money prediction market. You sign up for the market, we give you points to play with, and then we pay out cash prizes at the end based on how well you actually did. We're doing it for one narrow little thing. Will this paper replicate? This is one bit of information for the larger question you want to know. Is this claim true? Is this research study worthwhile? Is this field progressing? Where do we want to spend our effort? Well, how has this done? 4 smaller papers. If we pool them all together for the prediction market result, we see that we've just ordered all those claims, one per paper. And sometimes it's tricky to pick out the main claim per paper, but you pick out a prominent one that you think you can test. And this is, what did the prediction market say? 0 would mean we think there is no way, even by chance, this would replicate. So nobody forecasts that low. And 100 means, even if you mess up, it'll replicate. No one forecasts that high, so they get fairly close.
Clarification question. You said it's hard to predict out to pull out the main claim, but the market price is picking out a claim, right? And that's what they're.
We give you a claim.
Yeah, you give me a claim and a paper.
The author doesn't always agree that that's the best claim of the paper.
Yeah.
But they try to work it out with the author to pick one that's representative and could easily be redone.
Okay, so it's not, when you said that, it was just the way you said it, it was kind of hard to tell whether, but those are all a specific claim.
Each dot is one paper, and it's one claim from that paper. All these yellow dots were claims that the replication failed. So we did a high-powered replication, usually twice the sample size or more of the original. So it has more power to detect an effect if it's there. And these all failed. Right, there's 50-50. So the ones below 50%, only 4 of them successfully replicated. So we've got good signal there. It's not well calibrated, right? These numbers should have been way lower. The market was overly optimistic. But above 50-50, you can see that most of them are blue. Those did replicate. We've got signal there. We're hoping to boost that in a couple of ways. Well, what does this look like? If you go to the website in the brochure, right, you get the same slogan there. This is to bring you in, sign you up to play Reliable Research Replicates. You can bet on it. Hey, if you prefer, you can just do the surveys. Find a study that interests you. Right, in the market, you have all 300 to choose from. Forecast the chance of replication. Win prizes for being correct. What does it look like when you're there? Well, remember, first week of every month is surveys and then markets. You get a summary of the claim. I've left the actual abstract and title off here. And actually, there's a couple you could figure out what the claims are from the slides. Don't put that up on the internet, please, because until these are revealed, we're trying to reduce the crosstalk between our team and another team doing the same thing, and between our team and the evaluation teams. All right, what is the claim? Out of this whole paper with many claims, what's the claim we're testing? What is the test that they used? What results did they get? We'll pull out some key statistics for you to look at, like what was the p-value, what was the effect size, and then we asked you 4 questions. It used to be 7, but DARPA just simplified the definition of replication, so 3 of our questions, no longer relevant. What's the chance a high-power replication would find a statistically significant result in the same direction as the original? So we're going to remove the worry of small sample size, do it again. Well, the Center for Open Science is going to do it again. What's the chance they're going to get the same result? If you do a low-power replication, the answer here depends almost entirely on the low power of your replication. So you really want this to be as high as you can manage without wasting resources. This is a kind of tricky question that comes out of the MIT research on Bayesian truth serum. What fraction of participants will estimate larger than 50% on question 1? And what we're looking for is people, for rating the surveys before ground truth, we're going to look for people who are accurate on this estimation, because they may know something, particularly those who are accurate on that and surprising in what they say elsewhere. Considering the claim itself, right? How plausible is it? Is this a, wow, that would be fantastic if it's true, but it's wildly implausible? Or is this a, if you flip a coin 100 times, it'll come up heads about 50? Yep. And anything else we should know. I'm going to show you a live look at the market in a second. This was our older interface, so you can go look at all claims. You can browse by journal. You can browse by topic. And then in the claim, you get the same kind of summary information and then a forecast widget. We're just about to release a new interface that looks a little more this century. So same kind of browsing and filtering, just more up-to-date and more interactive, and we will take a look very soon. We found that a lot of people are not quite sure what to do in a market, which is understandable. There's those people who do markets all the time, and they say, what's this probability? I just want to buy and sell shares. We're going to try to support them as well, but we're really interested in what do you think the chance is? But in a market, unlike a survey, you've got a finite number of points. To move that slider, you have to spend more of your points the farther you move it. And so we've got a new widget that tries to show you if the original estimate was here. The farther you move it in this direction, the more you could potentially gain, up and green is good, but the more you could lose, down and red is bad. It was at 30%, so you're moving it back towards the middle before you move it up again. That works in your favor. If you were trying to go more extreme, you can see that you're paying more for less gain. We're trying to make that trade-off intuitive to people. What's going on here? Well, if you have it down here at 10%, you think it's only 10% likely, you should be willing to accept 9-to-1 odds on that bet. We've made some dummy accounts, 8 of them, so won't quite cover everyone in the room, but if you can buddy up with somebody next to you. There is a relatively recent study in judgment and decision making called Finding Meaning in the Clouds. Illusory pattern perception predicts receptivity to pseudo-profound BS. The hypothesis that I picked is participants who display greater degrees of illusory pattern perception, so seeing patterns that aren't there, in this case in series of coin flips, would also be more likely to rate pseudo-profound BS as profound. The pseudo-profound BS is generated by one of these natural language processing algorithms that just takes a series of words from plausibly profound statements and combines them randomly but grammatically.
Any examples?
I don't have any examples of the recombination. Yes. So they found support. So we're going to ask whether you would do the same. The link to the article is down there. If you go to dev.replicationmarkets.com/app to get the fancy new website, you can log in as C4I, capital I, .1, .2, .3, all the way through .8. And the password is C4I.1 underscore, lowercase test. Capital C, capital I, lowercase test. And you can go in and look at that. 201 participants in this particular study from Amazon Mechanical Turk. Had to be US residents, had to have done well on previous Mechanical Turk tasks. The study, they claim, was pre-registered. And we're going to focus on a particular effect. They said they're going to use BS sensitivity, which is how high did you rate BS statements minus how high did you rate plausibly actually profound statements. Written in the same style, but by a human that was trying to actually say something. So that's to remove the bias of, some people just think everything's profound and some people think nothing's profound. So they did a difference. All right, how much does that correlate with your perception of patterns in coin tosses? And the Pearson's correlation is 0.21. So it's kind of standard social science correlation. not super strong, but statistically significant to the 0.01 level. So they think if nothing were going on and there were no other biases in the study, you'd expect to see that kind of agreement 1 in 100 times. If you go onto the market, and I'll flip over here to do so, and try to drive sideways. All right, there's a little summary of it, and it looks like nobody has made a forecast yet.
I'm just trying to get logged in.
You're gonna grab 4? C4I.4 underscore test. No underscore, lowercase. All right. Now, you all have way too many points for just doing one, so try not to slide things way to extremes. But let's say I thought it should be 0.01. That's not great, but
You should refresh before you do that.
I should refresh. Maybe it's changed.
We do a BG test, is that the one? Or is it?
No, it's the Walker.
Walker.
Let me do a refresh. Oh, okay, it has changed. All right, so someone has moved it down to 35%.
That was me.
What is trade cost versus shares cost?
Trade cost is, suppose it resolved right at the mixture value that it's at now. What would you be paying to move it? And shares cost is, what are you paying to buy the investment in the outcome? We need a better way to explain those. All right, so if I disagree with Kathy and raise this a little bit, back to say 40, 42.
I'm using my background knowledge that a lot of claims don't replicate. And the fact that that central banks, that governments tend to not be very responsive to what the central bank tells them to do. Is my thought.
Yeah. So in fact, on the market, we start things not at 50-50 anymore, because we discovered if you do a tiny decision tree, you can be about 60 to 70% accurate. And the decision tree ignores everything about the study except the reported p-value. If it's the usual, p is less than 0.05, we give it only a 30% chance of replicating. If it's p is less than 0.01, we give it a 40% chance of replicating. This is based on the 100 studies that you saw dots of before. And if it's less than 0.001, we give it an 80% chance of replicating. And empirically, those are the rounded values, slightly squished towards the middle of what we found in the other 100. So that gives people a ballpark to start with. It lines up with Kathy's intuition about which way this should have moved to start with. And then we have them.
Tend not to replicate, and 0.05 studies tend even more so not to replicate.
Yeah, and 0.01 doesn't buy you as much as you think it might. The 001, that's where the evidence really seems to start to weigh in the past anyway.
This suggests, because the 0.05, the meaning of that is that if there is no effect at all, there's a 5% chance that I'd get a result this extreme. What that suggests, since so few of them replicate, is that people are doing a lot of fishing. They're running around like doing studies that don't come out significant and then doing another study that doesn't come out. The file drawer effect is what they call it, which is that you have all your non-significant studies stuck in your file drawer and you pull out the one that came out significant and publish it. And that seems to be the way that a lot of science is done.
Although that description, I think, is misleading in the sense that they're not really putting
No, they're not
20
putting it in
things in the drawer. They're just running 20 different versions of their analysis, right? It's
Right.
much easier to put variables in and out and change the form, structure and all that sort of thing.
There was a paper that was published several years ago, probably 20 years ago, by a statistician where they took they randomly generated some data that had no effect, and they threw it into one of these stepwise regression models that tries variables and throws things in. And it turns out that like a 0.05 significance level, like a 0.9, the opposite 0.9 is significance level is close to a 0.1 really. Because if you follow one of these kind of stepwise regression, we have lots of variables and we pull in you're pretty likely to get some combination of variables that's significant. In my classes, I call it phone book regression. You go to the phone book and you copy down 100 columns of numbers. And that's your X variables. And then you copy another column and that's your Y variable. And you regress the X against the Y and 5%, 5 of those 100 are going to come out significant.
I don't have a references slide in this one. Maybe I'll add it for archiving on the site. There's a beautiful paper called The Garden of Forking Paths, which is a reference to a Borges novel. But it's by the statistician Andy Gelman at Columbia. And a nice thing about that is the phrasing of the Garden of Forking Paths removes the accusation of fraud. He just points out that there are so many decisions you make in the analysis of your study, each one of which seems entirely plausible and well motivated to you, but when you've made 4 or 5 of these, what you thought was a p is less than 0.05 is now a p is at least 50% likely.
Mm-hmm.
You just move into successive subsets of physically plausible effects, but that your study really can't show anymore because you've unintentionally made a bunch of adaptive choices in your analysis.
I really don't think people are trying to be but there are a lot of competing motivations. One, there's a very strong motivation to publish something.
Yeah.
And you want to find something, and you believe there is something, so you keep searching until you find it.
It's the last one that really gets you.
Mm-hmm.
So feel free on your phone or laptop to keep playing with this. In markets, it's better to nudge a little and see what happens than to make one big change. For one thing, you have much more power. You saw the way that curve gets extreme towards the edges. If you nudge a little and then Kathy moves it back, you can keep doing that all day. If you make one big push and lose all your points, Kathy is going downhill to oppose you and can do that for insignificant cost, and then you're out of points. And so we don't get a real sense of what consensus would you two have come to. She just outplayed you. So we want people to move a little, come back, see what happens. And so you'll see that the market moves a bit over time. Up and down. All right. If we flip back here, we can look at some results that we can talk about because they're not for claims selected by the Center for Open Science. Going in, we knew we had 3,000 claims we were about to put in front of everyone. 100 to 300 would be tested, but they're from all different fields. I said, well, what do you all think? When we're done, what will the replication rate be in economics, or political science, or psychology, or these other fields? And how do you think it's changing over time? We're doing the last 10 years. In 2-year groups, what's it going to be in 2009 to 10 versus 2017 to 18? Oh, and what will the average rate be for the whole project? Which you'd hope is an average of these other rates. A good sanity check. So a snapshot near the close of the markets when we ran, this was round 0, before all of the regular ones opened up. So I think it was last August. I said, okay, what will the rate be in economics? And you can see it wandered around for a while, but it was basically oscillating well above 50, somewhere around 60, and at this snapshot was 63%. Why? Well, some comments aren't very useful. These two were, I think, replication rates are not much higher than in other fields. Publication bias could be even higher due to strong incentives. So this is somebody who is pushing it down. The second person says, incentives are powerful. Replication rates are probably higher here. So people moving things in opposing directions and giving reasons for doing so, trying to persuade other people. What about psychology? You can see that it's not oscillating as much, but seems to be somewhere around 40%. At the snapshot, it was 39. First person says, well, you all have been citing this past study, but I think it underestimates the replicability. And gives a couple of reasons why that might be so. So they're trying to push it up, where the second person says previous replication projects found about half the studies to replicate. Well, we ran these markets for a week, and so what did we find? On the left is years, 2009 and 10 on the left, 2017, 18 on the right. You can see slow increase over time. Not a huge increase. We go from about 40% to about 60%. But because of the number of, this is survey data here because it's easier to do the statistics on them. And because we had 200 or so surveys, this is statistically significant, I think, to 5 digits. So not a huge effect, but a reliable one. And likewise in the field, we saw economics was rated as the most reliable, somewhere around 60%, education the least reliable, and others in between. The three on the right are all statistically identical. So marketing and management, psychology and education, our forecasters, who may have been a lot of economists, thought those were going to come in lower than economics, and political science, sociology, and criminology in the middle. Political science actually distinguishable. The mean is not that far away, but the distribution is very different. Yes, there we are. So most of the p-values on the left are 4 zeros and a 1, and on the right, the ones that are different to 4 zeros, and the ones that aren't are just obvious that they're not.
Isn't that last year thing crazy? All these fields are suddenly going to become more like economics than like previous versions of the field in 4 years.
The last year, so
2017-18, it's got an average up there almost as high as economics.
almost as high as economics.
As if to say, in 10 years, these fields will have changed their character to become almost like economics.
I think
All right, that's a good point. Psychology is actually making a lot of changes, but right, will it get that far?
it's people though, right? I mean, this very well could reflect inherent optimism in the survey respondents, right? People could have the perception that things are getting better with time. And from an economics perspective, the market is also like the actual like our economics have been getting better over time, so that could also contribute towards positive feelings about the future too.
In the paper on the Google markets, they found that new employees were the most optimistic.
Right. Okay, so you would maybe keep the differences and slide everything down a little bit.
I think they're all suffering from optimism. Yes, expecting this huge change over this period.
Okay, reasonable. We did find infield versus outfield. So we asked people when they sign up to fill out a survey saying, what field are you in? We'd like it for our research, and it'll help us send you surveys that are a little more related to what you're probably used to. So how reliable do people think their own field is? And you see the distribution there is very broad. What about out of field? Okay, a little bit narrower and centered, but the really interesting result here is the difference between those two. And for people in most fields, there's not much of a difference. They think their field is a little worse than average maybe, but You can't say that reliably. Economists are really optimistic about their own field, though. We also did this with the market, and the correlations are really high. So, 0.92 was the lowest correlation between market-related stuff and survey-related stuff, which is nice to see because we don't have ground truth yet, and these are independent ways of getting at what do people think. In the survey, you're all on your own. You don't get to collaborate. In the market, you see what everyone else says and you react to it. Another way of showing that, partly because, I mentioned we are estimating from the surveys how well we think you're going to do and you're going to do, which is a bit of statistical black magic. The great talk the Harvard folks can give on that. The intuition, right, is we know that if you just take the average of a crowd, that tends to do better than the best person in the crowd. Not on any one question, but across like 10 questions, the average outperforms everybody. So one way you might do this is say, well, the closer you are to the average, the better you're likely to do. If you use a naive rule like that, it's very easy to game and it falls apart just about instantly. So they have an iterative process that attempts to do this in a slightly harder to game way, and we don't tell you exactly what they're doing to make it even harder to game. But we worry about it, so we do a lot of sanity checks. So we say, okay, what does that magic surrogate score do? How does it correlate with the smooth market on all the claims I can't show you yet? And that's pretty good. So we think we're seeing some stable signal there, or at least whatever people are doing in the market is being pulled out by the surrogate score. And how does the market correlate with the survey mean? Even better.
It correlates even better with the survey mean, but you don't want to use the survey mean because it's too easy to game.
Yeah, I mean, we're reporting it, and it could be that all of this statistical machinery is going to be outperformed by the simple mean. We would not be the first people to suffer that fate. But the hope is the SSR score is able to pick up a little more on, okay, these people, they're just not giving you any extra signal. Give them very low weight.
So the Good Judgment Project, they were able to find rules that beat the simple mean.
Mm-hmm.
They were able to identify people they called super forecasters who were really good at it.
They had a huge advantage we don't. They got to have questions resolved over time, and they could look at your track record.
Yeah. And that's
which,
how they figured out who was a super forecaster.
When we wrote our proposal, we thought we would have. And in the kickoff, it was revealed that for programmatic reasons, we won't know until everything's done. So, which also makes it harder to run markets, because one of the ways markets work is people who do well get more points over time, so they can have more influence. Instead of just one-on-one, you versus Kathy, you've done well in 3 previous rounds, you now have 3 times the influence. You can take on 3 people. We don't get that. We do get the market incentive to speak up when you know something and stay quiet when you don't, because your points are on the line. Alrighty, that is all of the prepared slides. I have backups, of course, if people want to get into a little bit of the Harvard rule, though that gets pretty opaque pretty fast. And I thought I might come back and refresh this and see where we are with our forecast. Okay. Sticking around Kathy's intuition. 40-ish%, yes?
Did anybody
38.
else get, no, I turned it back to 38. Did anybody else forecast?
It was just 3 of us.
Okay.
Okay.
Nobody else logged in. Oh, I thought we would have a battle.
I put 40%.
Okay, good for you.
If you read the paper, they do go on to look at visual pattern. The effect there was not as strong. So they said it did pass a statistical significance test with the raw BS rating, but not with the one where they subtract out your other tendency. So once again, it's like, well, how many tests were there in that paper? Each one a reasonable thing to ask, but if you ask 10 of them, then your statistics aren't reliably what you say they are.
So this is building on prior work, which had smaller sample size.
Yeah.
So if we do a value information calculation here, you're going to get more precise estimates on some parameters. Which of these parameters are the ones that, with more precise estimates, will enable you to make a different decision? You do something different than you couldn't have done with a smaller sample size.
So you don't mean about the individual papers.
No,
You
no,
mean
I mean
the
whole
estimate
project.
of replicability.
Right, it's something about the project, you're going to be able to get a more precise estimate. What number is that, and what can we do with it that we couldn't do with the less precise estimate?
You can answer that in 2 parts. We'll have a more precise estimate of overall or field-wise replication rates. I don't think we can make a lot of decisions based on that. But if we can get a reliable procedure, either, hey, you just keep doing these markets if you don't mind paying people the incentives and wrangling the crowd, or a combination of that and a machine learning thing that gets you 80% of the result faster and then some humans sitting on top of it, to rate individual papers, towards the goal of I drop in the PDF and you tell me, hey, this is really reliable research. This is cool, but it's preliminary. Don't make policy on it. I think that would be something we don't have now.
That's the machine learning part. But you already have the market part.
Yeah, you already have.
Smaller data set, right?
You already have the market part for a smaller data set that no one's convinced would scale.
So you're going to prove that it does scale against people's doubts that it scale.
Uh,
Are there people publishing saying this won't work?
Are people publishing saying this won't work? No, but nobody's using it.
Well,
And so the
But that
DARPA,
it may not be their doubts about
it
scaling.
may
because
not be
the
their
reason-
doubts about scale. The DARPA conceit in motivating it was, if we could get a black box, then people would use it. Because it would be fast enough to be nearly free.
You know, machine learning.
Machine learning.
But
Yeah.
you already have a black box.
Okay, you're right. A fast black box, a machine learning black box. My response is, yes, that's great, but it'll drift and be gamed over time. So you're going to keep needing to correct it. But it probably makes sense to have a hybrid system that gives you some combination of immediate scale and recalibration, because we're struggling to keep people rating 300 a month.
I think
Maybe
you
if
could-
it were taken over by Apple or Amazon or somebody,
Well, like you
You
said,
could
there's
get more
already a
pull.
60% black box. Well, that's not good enough. Do we know what number is good enough? I mean, how accurate a black box do they need? Or who has said, if you give me an 85% black box?
is
then I
anyone
will use it.
going to commit to that number for anything reasonable? I wouldn't make hard decisions based on where we are now, which is 70% plus or minus unknown epsilon.
Most of these journals are
80%?
projecting 90% of their submissions. I mean, so
That would
seem
help.
to me a 70% leverage is pretty good at it.
If I can tell you
Yeah.
which way the market's gonna move with 70% accuracy. I'd be-
Right?
Yeah.
And the base rate is still around 50%. So you're definitely gaining
Right.
a quarter of a bit there.
Typical journal, now it's 50% replicability. They could move it up to 70%. That's not a trivial gain at all, is it? But if they
Yep.
say, no, I won't move it up to 70%, even if I could, then you could move it up to 85 and they still wouldn't use it.
So I also see, because of the sponsor, I see this being used in a different way than you're putting forward. You're thinking of academic reviewers using this to review. I'm thinking of this more from if you're a policymaker, you have a black box that you don't let academics have access to. That when someone gives you a claim and says you need to make policy decisions on it, you can run it through there and it can be a second guess on the expert that you don't know if you can trust. And then that also makes it a lot more difficult to game, because you can't submit, trying to do a human version of a generative adversarial network to figure out what keywords they need to put in there to exercise the brittleness of the network. I mean, I don't know what their end goals are, but if I was sitting in their shoes and I was a large Defense Department sponsor sponsoring that, I would probably be thinking about my uses, not theirs. Because the Department of Defense isn't paying to solve academics' problem.
But those people could already use the 60% box, are they?
You mean?
Yeah, not that I know of. If they were really using it, then arguably this wouldn't have been a DARPA program. Because then it would be incremental improvements.
Right.
This is DARPA attempting to show people, hey, we can really have a substantial improvement here that's not on everybody else's radar.
So there's probably at least 1,000 policy people out there, organizations who use papers. If you do a survey and say, here's the 60% box, which of you want to use that? And would any of them say, oh, sure, we're really eager to use your 60% box to sort out a paper?
I think that people who actually use the academic literature and base policy on it, which is a subset of policymakers, some policymakers, probably are interested in whether those findings will replicate. But there are policymakers who make policy based on their emotional feeling of what they believe is true too.
Yeah.
But that prediction we could test now because we have a 60% box already. We could say, do you want the 60% box? We'll even help you with a little bit or something just to get them to tell you. But my experience is they almost always want prestigious sources because they're going to get pushback from whatever they're using it.
Well, if the 60% box became prestigious.
Yes.
So there's this
Then the journals would be
there's this
using it.
myth, there's this magical 0.05, for example, that everyone bows down to. I remember the Nobel Prize winning economist Herb Simon. I had the good fortune to take a class from him, and he told us once that he submitted a paper to a journal, and they came back and they said that he didn't have any statistical significance tests in it, so they weren't going to publish it. So he said he went out and he found the least powerful test he could find. And it was because it was one of those interocular, he didn't publish anything that wasn't an interocular trauma effect. So he went and found the least powerful test he could find, and it was 10 to the -6 significant or something. And so he wrote to the journal, you guys demanded a significance test, I found the least powerful one I could find, look, it's highly significant, and then they accepted his paper.
Okay. So I need to do more work on finding that. I think that policymakers may create their own black box. My guess is no one's going to fund that to maintain it. But if, say, Nature put a little meter on each of their papers, they might start using it. The Center for Open Science has had pretty good success in the last 3 years getting journals to add badges. They're just simple little badges that say, open data or pre-registered. What reliability practices did you incorporate in this study?
Does your single decision tree, you don't consider pre-registered there, do you?
We don't. But
Is it predictive, do you know?
I almost know. There's 2 studies now that have looked at the replication rate of pre-registered versus non-pre-registered studies. Pre-registered studies, pre-registered studies tend to get fewer positive effects in the first place.
Not surprising.
And far fewer have had an attempt at replication, but they usually get the same result.
So the thing that would make me sad is if this put a very strong negative damper on publishing interesting results that weren't pre-registered and are only at 0.05. I think they should go ahead and publish them if they're interesting, but they should be caveated. In other words, we have this sort of, we don't want to publish negative results, so we make it too easy to make results positive and then they don't replicate. But what we should be doing is publishing interesting ideas that have some promise so that other people can replicate them and see if they're real.
Right. If all we do is replace 0.05 with pre-registered,
Yeah.
then we'll find a lot of boring, but stable results.
Yeah. People, sometimes you look at it and you say, boy, and we also don't publish, you know who does publish negative results? Parapsychology.
Huh.
Parapsychology.
Okay.
Parapsychology, ESP
Mostly what they
research.
got.
Yeah, I was
Well,
gonna say-
one is mostly what they got, but
No.
the science community came down really hard on these guys and said, Wilder effect and all that stuff. A very highly respected social scientist once said to me, if this parapsychology, the results that are out there were in any field that wasn't parapsychology, they would be considered really strong because they protected against the Fowler effect. They published their negative results so that you can, and they replicated and they show their replications and they do meta-analyses. They do all these things that are supposed to be good stuff to do. But nobody believes it because it's parapsychology.
Yes, the inference there is either a reductio against methods used in other fields, or an inference bias against parapsychology.
Well, I don't think, you said bias as if it's a bad thing. If you're a Bayesian and you have a strong prior belief that these parapsychology results are probably bogus, then you're probably in good, you should have a bias against them.
Mm-hmm.
But that doesn't mean you shouldn't publish them, because maybe there is something there. Anyway, sorry.
So, but yeah, that's fascinating. I didn't realize they were better at publishing the negative results.
They are.
So maybe what academia needs is just 2 scores on every paper, like reliable versus interesting.
Yeah.
Just making the distinction to those 2 scores.
So is the long-term intent here that they're going to actually publish that data? So somewhere like the Allen Center will put it up, and then people can hold a competition to see who can actually build the best algorithm with that data?
So the data will eventually be published. Before that happens, there are already teams beginning to look at the forecasts, and when the results are known, we'll add the results to those to build predictive models. So DARPA's funding a couple of machine learning teams to try to figure out.
Yeah, that's a super small sample size for any kind of,
Yep. It's crazy.
any of those types of techniques. But it's not intuitive. It's not like there's not other examples.
No, you just have to bring an awful lot of prior knowledge to it, or a really effective feature detector, which we have for images now, but not so much for text.
But again, once you publish your algorithm, even in the black box, then people can just try lots of things against it. Like find a variation that says yes one.
Well, it becomes arms race at that point, right? Because then you release supplementary examples of people who published bogus stuff that didn't replicate. I mean, it still gets back to, you have to have someone on a regular basis replicating or failing to replicate results that continues to feed whatever system it is, whether that be humans sitting behind a thing, which in my opinion, I can't remember, I think you said humans aren't so easily fooled. I was like, that's bullshit. Humans are easily fooled all the time.
Not as.
Not by the same things.
I literally lacing things with buzzwords is sometimes sufficient to fool humans, even if they're considered expert level judges. Like we're susceptible to all kinds of problems and biases.
True. The machine is. Well, I was going to say the machine is typically not fooled by prestigious authors, but there is no guarantee of that. That's a bit of text to be trained on, just like everything else in the paper. Yeah, someone recently had an editorial relaying their experience as a reviewer, where they'd been given a paper. It was by prestigious authors in the field. It was an interesting result. And so they read the paper from beginning to end, starting with why are we doing this, which was great motivation, and said, wow, that's really cool. Recommend for publication. As soon as it was published, a bunch of people started attacking the methods, and this person said it was obvious once they pointed it out that it was just nowhere near enough sample size for making that, and didn't see it because it was authors that I knew with an interesting motivation and claim.
The badges thing is interesting though, because like I look at a lot of engineering papers, just the world of living, right? So,
Yeah.
Publishing data, and the other big one is publishing code. Because when you make a
Yes.
claim that you did X, Y, Z, okay, publish your data and then publish the code you ran on the data to get the plots you got out of it, or to train your algorithm or whatever else. Because that's huge. I find so few papers that I actually have the code so that I can replicate it.
Yes. They actually have a bunch of these, but there's two that I happen to be carrying around.
Open
And
materials.
yeah, so you can stick them on your laptop. You can get badges to put them on the journal article for cooperating journals. And yeah, they've started to study the effect. It's like it's just a bunch of pixels. But people do seem to care, and they do seem to pay attention to it. So that's been encouraging.
When you say pre-registered, is that like someone saying, I'm going to go study X, Y, Z, and I expect to find, you know.
And here's the test I'm going to run.
And the methods.
And what you find out, as we're finding out, is it's tough. The earlier you set out your methods, the tougher it is to stick to them exactly.
Oh, yeah.
Stuff just comes up that you don't expect, like DARPA changes the definition of replication on you. But it really constrains what you're doing later, because it is natural to try exploring a bunch of stuff. It's like, okay, I'm not seeing any pattern here. On the other hand, wow, that data doesn't look normal at all. All right, let's transform it.
And that's not how science is done. That's the problem. That's why I'm saying that I think if we make that the way you have to do it, we lose something.
Well, if we make it how you have to report it, right? Say, okay, here's what I found, but you know what? I didn't plan to do any of this going in. So what I thought was a confirmatory study is now a new exploratory study.
If you bill it that way, that's great. Yeah.
So
If you can still publish exploratory studies.
so the top econ journals have apparently adopted the new standard that you don't show any p-values whatsoever in the paper. Of course, you do show your standard errors, so that means the reader just has to start going through and trying to divide in their head.
That's true, but I'm sympathetic to the decision. Now, partly because I worked with Fiona Fiddler during her graduate work, which was attempting to get psychology journals to drop p-values for a bunch of reasons. And the argument is, yes, they're logically equivalent, but they're not psychologically equivalent. And the errors people make when they look at—
anything else to look at, and I have to go calculate it myself. You're not saving me any trouble.
if you have to go calculate
If you
them
give me
yourself,
something else to distract me my attention with instead,
so they don't do
then I might
confidence.
look at that. But
They don't
instead
do-
of just nothing.
Oh, they just do nothing.
Just the estimate and the standard. That's it.
Okay, right.
No other.
But I still
Fiona's
don't know
recommendation
whether
is
you
confidence
think-
intervals.
I still don't remember whether you got the hypothesis that you're producing that estimate for. I don't know whether you had that,
Right,
whether you
sure.
thought of that coming in or whether you
Sure,
explored
that's not,
15
this isn't
different
about
things.
pre-registration. It's
Yeah.
just about.
So they just don't report them. Okay.
That's weird.
Yeah, I agree. You want to give somebody something to look at. And yeah, it may be that that's going to have just as bad effects, but different ones.
Right.
And we don't know because we don't have everybody doing it. But
Right. I mean, it's analogous, say, to jumping on people about talking about race incorrectly. And then the response is never talk about race. Which is that an improvement?
right. Yeah, Deborah Mayo's been writing about that. Because you're just removing p-value from the vocabulary. It was doing something, even if often misused. Oh, very cool. Thank you all for coming out.
Thank you.
Hold me out there.
Good.